This is example 9.2 from Discovering Design with Chemistry. A solution is made by measuring out 150.0 grams of calcium nitrate and dissolving it in enough water to make 500.0 milliliters of solution. What is the concentration in moles per liter? All right, so what are we given? We're given the grams of our solution, which is calcium nitrate. So that's a messy C. CaNO3. Now calcium is right here, that's +2, and nitrate is going to be a -1, so that means we're going to have a 2 right here. All right, and then dissolving it in enough water to make this much of our solution. So there's our grams, or our mass, which is in none of our problems lately, so we know we're going to have to do something with that. And then this is our volume. Now the question asks, what is the concentration in moles per liter? If you're following along with the example and you just got to this part in the book, that means what they're wanting to know is the molarity. And that is moles per liter. So moles of the solute, in other words, moles of our calcium nitrate, and liters of the solution. Well, they gave us the liters. So to figure this out, we need the bottom to be in liters. So we're going to have to make a conversion there. And we need the top to be in moles. So what we need to do is we need to take our 150.0 grams and we're going to convert that to moles. And that will go on the top. And then we're going to take our 500.0 milliliters and we're going to convert that to liters. And then that will go on the bottom. And then we're ready to start. So let's scoot this over so we can make a little bit more room. All right, so we need to know what our conversion rate is to change our grams to moles. That means we need to figure out what the calcium nitrate is in grams per mole. So we're going to use the periodic table to do that. So calcium here is 40.08 and nitrogen is 14.01, but because of that 2 on the outside there are 2 of those, and then oxygen is 16.00 and there are 3 of those, but it's also doubled by the 2 on the outside, so there are 6 of those. So when we pull that up, that tells us how many grams per mole. All right, so let's pull up the calculator. And pretty soon, when I feel like it's probably the point where you're comfortable doing these, I probably won't work through all of the getting the conversion factor. All right, so this is 164.10. So 164.10. And we got to keep the all the way to the hundredths place because we're working with precision. So that's how we're going to convert our grams to moles. And then our milliliter to liter is just that we have 1 liter per 1,000 milliliters. All right, so let's convert them one at a time. Let's grab a different color. So first we're going to work with this one. So we have 150.0 grams. We're going to multiply that by the conversion factor that we just found. Grams on the bottom, moles on the top. For every 1 mole, we have 164.10 grams. And we're multiplying, so now we care about the number of significant figures, which in this case is 4 because of the 150.0 divided by 164.1. All right, so in this case we have 0.9, oh yes, so 0.9141. 0.9141, and that is moles because our grams canceled. All right, excellent. Let's scoot this up a little bit. Let's pick a different color. Now we're going to convert our solution amount from milliliters to liters. So we have, you can just move the decimal if you want, but if you're still unsure about that, you're welcome to keep doing it this way. We want milliliters to cancel. We want to change it into liters. For every 1 liter, we have 1,000 milliliters. And then we divide. 500 divided by 1,000 is a half. So we're going to keep all of those zeros because the all of these are significant, and the 1,000 is exact, so that doesn't matter. Now we have our two numbers. We have the moles and we have the liters. So now we can divide those two and find the concentration in moles per liter. So we have 0.9141 moles, and then we have 0.5000 liters. .9141 divided by 0.5. We have 4 significant digits in both those numbers, so we're going to keep 4, so 1.828. 1.828, and we can just abbreviate molarity with a capital M. So that's the answer. All right, so we started with grams and the name of a substance that we needed to, the name of our solute that we needed to turn into a chemical formula, and then the amount of the solution, and then we just had to convert the two numbers they gave us into the units that we're allowed to use to figure out concentration in moles per liter.